example. So let's say I look at find the Taylor series. For this function, same one, e to the x, but I'm going to do it now at a equals 2. So I'm going to stick to making that same table I made before. Let's see if n, the nth derivative of your function. But now instead of plugging in 0, we're going to plug in 2, our a value. And the very last column is for our actual coefficients we're looking for. The nth derivative, plug in 2 over n factorial. Okay. So I'm going to plug in n equals 0, 1, 2, 3. So when n equals 0, we aren't taking a derivative, we're just writing our function e to the x. And this column is going to be the same because we're just taking derivatives here. We're not plugging in anything, e to the x, e to the x, e to the x. Okay. So here's where it's a little bit different than last time. I'm plugging in 2 now instead of 0. So I'm going to get e squared, e squared, e squared, e squared. Okay. As I'm plugging in 2 for x. And now you're just going to take these entries that are in this third column and I'm going to divide by n factorial. So it's going to be e squared over 0 factorial, e squared over 1 factorial, e squared over 2 factorial, e squared over 3 factorial. All right, too big. So these are our coefficients of our Taylor series right here for us. So I'm going to start by writing out the terms and then we're going to come up with a formula. Okay. So this is centered at 2 now. So the formula for your series is going to be Cn, it's going to be x minus 2 to the n because it's centered at 2 now, so it won't be x to the n anymore. And you start writing out things and trying to notice a pattern. So let's start with our constant term, e squared over 0 factorial, e squared over 1 factorial, x minus 2, e squared over 2 factorial, x minus 2 squared, then it would keep going. Do you see a pattern?
Wow, the first one is 0. Yeah. Oh, it's 0.
You're okay. Your power is 0. Mm-hmm. So you've got to come up with this formula. N equals 0 to infinity. So what should be in my formula? What's the same in every single term? E squared? Huh? So I'm going to put that in all of my terms. So I'm going to write e squared. And then in the bottom I have these 0 factorial, 1 factorial, 2 factorial. That's still n factorial. And then the only part I haven't accounted for is this x minus 2 to a power. So it's x minus 2 to the n. And this is my Taylor series, centered at 2. Okay. Now this question didn't ask for the radius of convergence. If it did, you would use the ratio test again. But I'm going to go ahead and tell you, if you do that, you should get the same radius of convergence as we did before, infinity. Okay, so if you want to check that, you can verify it. So it's kind of formulaic, it's kind of systematic. I use that table to help me write out these terms. And then I have to notice a pattern. Once you notice a pattern, then you can write a formula in general. Formulas are really just patterns that you notice, okay? Things you observe.